Good morning, everybody. We're in the second part, basically, of the course. We are in the portion that deals with chemistry now, or actually the third part. We still have another exam that is coming early in November. Excuse me. Before the last exam that's going to deal mainly with geology and astronomy. So we have two more exams before we can call it basically a course. So we're midway, actually. Week 8 is exactly where we're supposed to be, in the middle, and I think we are there. Now, in terms of assignments this week, I think there are a couple of assignments, so please don't forget them. I know we have had just our exam. And before anybody asks a question, I did not review the grades that Canvas has distributed yet. Usually I go through that automated grading by Canvas and review them manual for partial credit, as I promised before in the past. And before we started the recording, actually I was let's put it in a different tone. Okay, let's put it correctly. Okay, I was whining a little bit about being busy this week. Okay, so hopefully by Friday and Saturday, I should go through the entire exam basically and how it was graded by Canvas, and make sure apply extra credit whenever it's applicable, of course. Okay, so that you guys will see your final grade for exam 2. Other than that, we're going to continue basically with the chemistry portion, and today is chapter 14. Okay, and that's why you see this periodic table behind me, because we're going to get into a little bit of the role of chemistry and how it relates to other branches of science, number one. We also are going to get into the differences between chemical and physical properties, since we've dealt with mainly up to this point with the physics. So we're now trying to understand a little bit different aspects of physical science, namely chemistry. And so we'll see the distinction in there, and then we're going to end it with naming, basically how to name compounds, compound naming, which is critical for you guys because you will have an assignment, which is part of a homework dedicated specifically to this chapter on how to name compounds. So, and the assignment is actually, there is only one attempt, but that attempt is an open-ended. So basically when you start it, do not start it unless you think that you have plenty of time to go through it. So if you think that, for example, you're busy, you have to go do some shopping or do some stuff at home or work, don't try to start it yet, okay? Start it when you have at least, looking forward that you have at least about an hour, possibly more, so that when you start it, you have plenty of time to go back through the book, review the questions, review the references that you wish. Talk to me if you want to, if it's not too late, okay, at night. Consult one of your classmates, and at the end, you have an understanding of what the answer is. This is a homework assignment, meaning you have the total freedom to basically consult as much resources as you think is needed and work together on it. There is no objections on that. The bottom line is that you know how these things work, okay? So don't start it if you only think that you have 15, 20 minutes probably to spare. That is not good because it's only one assignment. There is no time limit, but there is only one attempt at it. You guys understand in terms of how this homework is structured, everybody? Yes?
Yep.
Very good. So we're going to basically go to chapter 14 now, if I can find it. First of all, I need to chapter 14. Here it is. And let me do some cleaning behind the scene because I saw something I shouldn't be have it open. Okay, good. So we're supposed to be looking at the PowerPoint from chapter 14. Is everybody looking at the same thing? Yes? No? Maybe?
I can see it.
Okay, very good. Thank you, Sher. Okay, sometimes I need a verbal feedback because when I am in the sharing mode, I don't see the chat. So if people are putting things in the chat, I have to I have to go between the two, and that's not good. Okay, anyway, So we're going to talk about elements of chemistry. So this is really an introduction. We still have more chapters down the road. I think all the way extended to chapter 19. So we still have quite a few chapters to cover before we finish this section. So again, we're going to talk about the role of chemistry and where it stands in terms of its relationship with all the branches of science, especially in terms of physics and how it relates to it, because they are closely related actually. In a sense, chemistry has some applications directly from physics, so it's really important to see that connection. And also in terms of its applications and implications on other branches of science, especially biology, for example, and also uh, earth science, geology, which is a big connection between the two. Without chemistry, we would have very hard time understanding both. So it's important that we see that connection. And the second, the third, the last branch of science that we're going to focus on, and this is going to be part of our course also, is astronomy, because chemistry plays a major role in terms of basically the geology of the planets and what's going on in their surfaces and what's going on in their atmospheres and what's going on in their and also the stars too. Although the stars in their core, it's a completely different process. It's not chemical processes, but nuclear processes. But at the end, they start forming other compounds, and that's basically they are also part of. There is implications of chemistry in those things too. So chemistry plays a major role in everything, and that's why it's important for us. So in terms of biology, not only the internal processes that happen in living systems like animals and plants, but also in terms of drugs and other things that are used by in the industry. So there is all kinds of connections for chemistry with other branches of science, and it plays a central role in this sense. We will talk about the atoms and how tiny they are, and you will see that they are so small, basically, relatively speaking, compared to anything else. And again, I mentioned that from the beginning, and that is the physical and chemical properties and how we distinguish between the two. And sometimes when we are doing chemistry, we invoke physical properties. And sometimes when we're doing physics, also we invoke chemical processes. So it's basically there is a two-way basically connection in there. Again, determining physical and chemical changes. Some of them involve the change in the actual, basically, rearrangement of the actual atoms of the matter, and that is chemical changes. Whereas in others, they don't involve that. They keep the elements basically or the compounds the same, but they change their appearance or they change their physical properties. And that is the physical, basically, changes, physical reactions. And we'll see what is common between them, and namely that the fact that both changes can change the physical properties of an object, okay, or a compound. We're going to basically see how compounds are made up of elements, basically, and then we're going to name compounds. Remember, there is an assignment at the end of the end of the chapter on this. Okay. So again, chemistry is the study of matter and transformations it can undergo. Okay, and this transformation involve the changes in matter itself, internal changes in matter. Okay, again, I mentioned the fact that chemistry plays a major role here, for example, in terms of metals, in terms of basically uh, minerals and things like that, and also in terms of geology. And here is a case, for example, when we went to Mars, one of the things we did was, I mean, Mars, the moon, we wanted to basically see the geology of the moon and the chemical processes that were involved there. So again, it plays a major role in with different branches of science. So, and in that sense, it's really it plays a central role. As I said in here, it's internally connected. I mean, it's intrinsically connected with physics. There is no question about that. In order to understand chemistry, you cannot do it without physics. As a matter of fact, the processes involved with heat exchange and all of that. They start as physical processes, but they lead to changes in structure itself, which are chemical, basically, phenomena. So there is a connection between the two, a very, very intertwined connection between the two. And also in terms of how it's related to biology, and I mentioned the biological systems, basically, and how they react and interact themselves using chemistry or chemical processes, and also in terms of drugs and other things that are basically involved with any biological system. Okay, astronomy is very connected to it too, especially in terms of how astronomy is related to also geology and earth science in general, specifically to Earth. So this is the central role of chemistry, as I mentioned before. Again, material science, and I mentioned a few of them there up there. So we have all kinds of materials and new materials, and they're rooted actually in chemistry and physics too. So there are processes there that involve chemical reactions. So this is just basically an introduction to chemistry and how important it is. So most materials now, they involve some sort of a chemical process that we have in our household or we're in the industry. Here is an example, for example, in a kitchen, okay? See everything in here from what makes the kitchen itself, the cupboards, all of that, to what is inside and makes the refrigerator work, to all kinds of what brought this food, for example, in terms of fertilizers, in terms of, for example, the cookware itself made up of metals and different kinds of chemical processes that led to that one. And in terms of also power generations, which involve some sort of a chemical process, for example, using either fossil fuel or whatever process. So all kinds of processes in here involve on a daily basis. Wherever you look, there's chemistry. So it's all over, okay? So again, it has also a lot of influence even in politics and in terms of decision making, because it involves these processes everywhere. In terms of the structure of the atom, in terms of all of these things basically and how they look like, I know that I have behind me the periodic table, and it is in here for a reason, is that the atoms themselves are so small that if you take, for example, a grain of sand, it has so much basically atoms in it. So if you try to understand that number and how big it is, this is how big it is. You have to bring about 250,000 dunes of sand like this one and count the grains in them. That's a huge task if you can think about it. You just take a handful and you try to count how many sand dunes in there. Sand dunes, grains of sand. It's an impossible task. It's a huge task, let alone to have a sand dune standing by itself in here, let alone to have about 250,000 of them, 250,000 of them. That's a lot. That is how many atoms in one grain alone. Okay, roughly that number. So it's a huge number. It's a lot of, it's a very, very tiny, small size to account for that many into that small piece of a grain of sand. Okay, so just to give you a rough idea of how these things are. Okay, this is kind of a question that, of course, molecules are made up of atoms. It's not the other way around. Again, here is the physical and chemical properties, the difference between them. In terms of physical properties, it's basically how they look, how the size that they occupy, and physical sizes basically. For example, for gold, it's an opaque metal, meaning that it doesn't transmit light through it. You put it like, for example, the wall, you can see behind it. It's also yellowish in color, so it has specific color. And that means that it absorbs all the radiation of the sun except the frequencies that are combined to give you the yellow color. And also at 25 degrees Celsius, which is room temperature, ambient room temperature right now, it's solid. It's physically solid object, and its density is 19.3 grams per cubic centimeter or milliliter. This is a very, very dense metal. Okay. The reason why I'm mentioning this is because I just came out of an exam for another class where they're supposed to calculate the densities, and some of them were having, I mean, I always emphasize on these things. Try to remember things, okay? 20 grams per cubic centimeter is a big, dense metal. I mean, this is the case for gold. Iron, which is a daily common metal, it's about 8 grams, actually a little less than 8 grams per cubic centimeter or milliliter. Meaning that gold is more than twice as dense as iron. So if you find in a calculation 100 grams per cubic centimeter, that is super dense stuff. There is no thing that I know of that reaches that density. So you should be alarmed. You should say, oh, I made a mistake in here. This is 5 times as dense as gold. What kind of metal is this? What kind of material is this? It doesn't exist in real life. So that is my point in here. Diamond, which is also has some physical properties that you can see, it's transparent. That means it doesn't basically reflect any radiation that you can see or significant radiation that you can see for the most part. That's why it's colorless. That's why it doesn't reflect specific frequency so that it looks specific color. At room temperature, ambient temperature is solid. Actually, it's very, very abrasive material, so it's used in the industry actually to sharpen things and basically cut through stuff. Okay, and its density is 3.5 grams. So if I take both of them, the gold is supposed to be very, very heavy compared to with the same mass, with the same volume, I should say. Gold is much, much heavier than diamond. Okay, and other physical properties, for example, just not to mention just the solids, of course, we have in here water. Water also is transparent. It's colorless. The light that comes through it goes from the other end. And its density, it's a rounded number. It's one of the easiest things to remember. It's 1. Okay, 1 gram per milliliter or 1 gram per cubic centimeter, it's the same thing. Milliliter is a cubic centimeter. So these are physical properties. This basically describes the object of how we see it. It's liquid. That means that it flows, okay? And like solid, which doesn't flow, okay? I mean, unless we're talking about amorphous solids, which they flow over a long, long period of time. Now, so physical property describes how the object feel and look, and also some other properties that are not mentioned in here in terms of conductivity and other things and how they conduct heat and electricity and things like that. A chemical property describes the tendency of a substance to transform into another one, into another new substance, okay? So this is, for example, a chemical property, which is rusting, okay? Rust itself is actually a chemical property transferring iron from iron to iron oxides. Okay, so you leave iron outside, and the elements is going to interact with the oxygen and basically change to different element, which is now oxides of iron, which is different one. Okay. Physical change in this case involves the transformation from phase to phase. For example, it's still the same H2O in this case. It's still the same water. It did not change. So in terms of the chemical structure, it's 2 atoms of hydrogen combined with 1 atom of oxygen to give you H2O. Okay, no problem. So basically, excuse me. So Josh, there was no question yet. Okay, I know that some of you are worried about that. So the question is coming down the road, at least one question, and then probably potentially more. Okay, so you didn't miss in terms of the assignment for today. But in terms of the physical properties, as I was saying in here for water, so it can be a solid phase, it can be a liquid phase, and it can be a gas phase. And this is basically depending on how much interaction there is between the different molecules that make up the water. Okay. A chemical process, though, involves real changes in the substance. For example, on the far right in here, I have copper changing into carbon dioxide. I mean, interacting with carbon dioxide and water to form this basically substance in here, which is the which is called patina. Okay, and then baking soda also reacting with the vinegar. Okay, to form carbon dioxide in this case and water. So you have completely different materials altogether in this case. Okay. And you have, of course, methane interacting with the oxygen and then producing a lot of heat in this case, okay? And again, producing different elements in this case, namely water and carbon dioxide. So again, these are chemical processes. Now you start with one thing and you end up with something completely different. So that is basically the essence of the difference between the two. I mean, some of the differences in actually, you can have the same number of elements making the compound, but the way that they are arranged can have different, basically, chemical properties, not just physical properties. So the same elements, basically, that enter in the reaction will end up in the after the reaction. So for example, in this case, I have 4 atoms of oxygen. These are the red small spheres in this case. I still have 4 of them. They didn't change. I still have 1 carbon atom in this case. I start with it. At the end of the day, I still have only 1. I did not invent another one. I have 4 hydrogen atoms in this case. And after the reaction, I still have 4 hydrogen in this case, but they rearrange themselves into complete different chemical compounds. Basically, I start with 2 oxygen, what do you call it? O2s, okay, which is the oxygen basically that we see in the air, and combine them with methane. That's this reaction. That is this one, okay, to the one on the right. I mean, I'm sorry, on the left, okay. Combine them together now, add a little bit of basically heat for the reaction to start, and I will get a lot of heat after this, okay? That generates a lot of heat from this reaction. So they scramble together and they rearrange themselves. Basically now I have we have 2 water basically molecules and one carbon dioxide molecule. So basically that's how this reaction is happening. So I start with 2 molecules of oxygen plus 1 molecule of methane. And at the end of the day, the methane is gone, the oxygen is gone. I have 2 different things completely. So this is a gas, or at least the liquid compressed into a liquid. Then once it comes out, now I'm going to have this one in the gas form and this one is in the gas form. So physical properties have changed, but in this case, the structure itself, the chemistry also has changed. So this is a chemical process. Whereas, for example, in this case, if I heat the water, the physical properties change from being solid to liquid and from being liquid to gas. So the physics has changed in this case, but the chemistry stayed the same. I still have H2O. So that is a big distinction. Both of them can involve physical changes in the physical properties, but only one of them involves changes in the actual chemical structure itself. Okay. For example, this is another chemical reaction. It's already answered it. Okay. You have 3 molecules of oxygen combining to form only 2 molecules of ozone in this case. Okay. So in other words, the bonding between the oxygen and the oxygen has changed to a new structure, to different bonding, and it's still oxygen. So the bonding has changed so that now it involves, instead of just 2 atoms of oxygen, It involves actually 3 of them in each one of them. So O2, 3 O2s giving you 2 O3s. So this is a chemical reaction because now I have different element, a different compound completely. So the key word in here is the same material. Physical change imposes a new set of conditions on the same material, whereas a chemical change forms a new material with its own unique set of properties. So the properties now can change. So in both cases. So both physical and chemical changes result in changes in a physical appearance. Melting a piece of solid gold, so basically raising its temperature, being from solid gold to now liquid gold, is a physical change. This involves a phase transformation only. It does not change gold to something else. Tarnishing a piece of silver would be then a chemical process because tarnishing involves basically changing the silver to silver sulfide. So in this case, that is that's a chemical change. Okay, sulfur sulfide is different compound than silver itself. Elements are material made up of a single atom. Okay, pure gold is an example as it is made of any gold atoms. So basically, of only gold atoms. An atom is a unit for element. Sometimes we use them interchangeably. So when we're referring to an atom, we sometimes refer to it as an element and vice versa. That's because an atom is the unit for what an element is. But an element technically is a macroscopic quantities because remember the original example with the sand dunes, it's really all of that much just to represent the number of atoms. So in this case, you cannot really talk about it in terms of the microscopic structure, but element is everything that we can see with our own eyes on the macroscopic level. The formula in this case is used to represent what an element look like. For example, oxygen, that one that we see in the air, is O2 because you have two atoms of oxygen forming the unit in this case of this element. The ozone is O3, sulfur is S8, and gold is pure gold. There is nothing else with it. That is pure gold, of course. Again, a compound now is made up of 2 or more elements in this case. So in this case, for example, you have salt, everyday salt, and NaCl, which is made up of sodium and chlorine, okay? So, and in the other example, you have ammonia, which is made up of nitrogen and hydrogen. Compounds, of course, have properties uniquely different from the elements from which they are made. Remember, they're different than what you started with. Sodium by itself has different properties, chlorine has different properties, but now together they become salt, everyday element that we can take. Sodium is a very dangerous element and so is chlorine. But together they make up a safe element. Actually, it's necessary for everyday food. Here is the reaction that I was talking about. You have a metal, okay? Add to it chlorine, which is gas, okay? Get them together in a chemical reaction, and now you end up with salt, okay? Here is the task for today. I'm going to copy the link in here for you guys. So this is the question for the discussion tonight, okay? So I'm going to copy the link. I'm going to go to the chat session and give you that one so that you can guys grab it. Now, if you are not live with us today, you have to contact me to give you that link. So when you reach this point, you know that there is a connection that I'm going to give you. So you let me know and I'm going to send it to you so that you do the same thing. So this is the link that you guys are going to go to it. You're going to tell me the physical properties of sodium based on what you see from that link. Basically, what is the color and how it looks like, okay? Solid, liquid, and all of that, and the precautions you have to take to have this sodium. So that is item number 1. Item number 2 is going to be the chemical reactions of sodium with both oxygen and water. Again, if you go through that link, it should be easy to see how those things are, okay? How it reacts and what happened to it, okay? The first, in terms of chemical reactions, it's the color. You see the change. Of course, you're going to end up with, since it's with oxygen, you're going to end up with an oxide of sodium of some sort, but the color changes of the metal itself, at least the upper layer that forms on it. And the second one is you're going to really see how it reacts with water. Just put a sample of the sodium in water and you see the reactions. So that's the assignment for today. That's for the discussion for today. Does everybody understand what needs to be done? Yes? Very
Yes,
good.
got it.
Okay, very good, guys. Listen, so that's the link. Now, the people who are not here today live and they're going to watch this recording later on, they really have to contact me to give them the link because actually, if they pause the video long enough, they should be able to copy it or at least type it from in here. Okay, it's this link. Otherwise, please let me know. Okay, and I'll be more than happy to share that with you. Okay, and the assignment too. Okay, so that's basically in terms of sodium and how it reacts with chlorine in this case. And you see that you start with different elements that have different physical properties and you end up with something completely different. As a matter of fact, two things that are completely not safe, and you end up with something that is needed, okay, for our consumption. Again, just like the formula, for example, for the elements, the chemical formula for compounds also, it uses the different elements that makes it with their proportions. For example, 1 atom of sodium corresponds to 1 atom of chlorine to make up sodium chloride or everyday salt. Ammonia in this case is made up of nitrogen and hydrogen you have 3 of them, so NH3, and water is made up of 2 atoms of hydrogen and 1 atom of oxygen, making H2O. So this is what we mean by a chemical formula, okay? Now, how do we name compounds? This is critical now for your assignment. You start with the left in the farthest left in the periodic table, okay? So you see the periodic table behind me in here? I'm going to step up to the left of it. So on this side is the left, and then you start moving toward the right, okay? So that's basically the rule from it. So you start from here. You don't start from here. I'm trying to point to it. You start from the other way around, okay? So you need a periodic table for this assignment in front of you. So if you can't, please let me know and I will be more than happy to share the one that I have with here, and you should have no problem with it, okay? The only thing is sometimes when you're doing your assignment, you have to be careful. For example, there are so many B's, so you have to know the difference between the B and the BI and the BR and so on and so forth. So you have to really find where that element is when you're trying to find your names in there, okay? Okay, so where was I in here? So the first rule is you start from the farthest to the left in the periodic table. That's 1, okay? Then, for this element to the right, add the suffix ide, IDE, okay? Example, sodium. Let's go back into the NaCl, okay? To see how this works for it. Oops. Okay, for sodium, Na should be on this side. What is my hand? Okay, Na is here. Okay, and then Cl is all the way here. I'm trying to look at the screen and trying to look at it. There is no picture behind me, guys. You have to know that. Okay, this is a virtual picture. So this is the chlorine. So I start from sodium and then go to Cl, chlorine, but I'd add IDE to it, so it becomes sodium chloride. So that's how the name for salt is actually scientifically. Okay. And this is exactly what I was doing earlier with my screen. Okay, so you have sodium on one side, chloride on the other side. You start with the furthest to the left, and then you go to the right, and you add IDE to it. Okay. If you have different combinations, for example, and we will see that, then you have to add prefixes to those stuff. Okay. So, for example, if it's one, you're going to say mono, di, tri, and tetra. Okay. So that's basically how you add these things to it. I don't know if there is 5 and okay. For example, you have two possibilities. One of them is CO and the other one is CO2. So let's see how we can name this thing in here, okay, ourselves without having to go through the next slide. So carbon, where is my hand? Yeah, carbon is here, okay, and then oxygen is immediately next to it. So we start with carbon. Carbon, and then I have oxygen. I have two possibilities for oxygen. Either I have an O or I have two O's, okay? So it's either carbon monoxide or carbon dioxide. So basically I covered both of them, okay? So that's the naming of how this, okay, so let me go back into the screen where we were. So I solved the problem both ways. So I use both rules, okay? Rule number one, I use the rule number 1 and rule number 2, okay? Both of them for these things in here. So I added the prefixes now. For H, hydrogen and oxygen, when they combine, I have again two possibilities. Again, I start with hydrogen and go to oxygen. But I have two hydrogens in here. I really don't have one, okay? I have dihydrogen monoxide and dihydrogen dioxide. So technically, this is the naming for this two elements in here. It is two compounds. The first one, of course, is commonly known as water. The second one is commonly known. Does anybody know what the second one is? Somebody who works probably in a pharmacy or something? I am allergic to alcohol, so whenever I am injured, I cannot take alcohol. I take this one instead. This is basically what it is. It's called hydrogen peroxide, okay? And it's used as cleansing things, just like alcohol basically is used when you have to clean some bruises and things like that, which happened to me over the weekend in a soccer game. So I had to use it. Anyway, so that's again common name for it too, hydrogen peroxide. Okay, so again, that's a quick question here. Would you drink this? Does anybody know that is it safe to drink? Or does it remind you of a famous politician?
I think you can. I think you can drink it. I know you can brush your teeth with it, but I don't know that I would drink it.
Would it cure COVID?
Are you Trump?
I don't know. I don't think it's safe, honestly. Okay, so don't try it. Okay, I think it's probably very, very diluted. Maybe. Okay, maybe with a lot of water, so that its effect is minimized. And I heard people who said that you can, but don't. Okay, just like bleach. I don't think it's gonna work with COVID. Anyway, so this is basically the common names of these ones in here. So sometimes we can use those things instead of saying dihydrogen monoxide, we can just say water. It's the same thing, okay? Same thing with dihydrogen dioxide. So it's the same thing in this case. We call it hydrogen peroxide. That's the name for it. That's it's. If you go tomorrow to probably a pharmacist and you ask for it, oh, you mean hydrogen peroxide? Yeah, we have it. Okay, so that's something that. So again, this is the naming. Okay, this is the last rule. Actually, common names are sometimes used for convenience. So that's rule 3. So here is an easy example in this case. Again, we have carbon and bromine actually with it, okay? So let's see here how we can do it on our own, okay? Of course, the correct choice is D in this case, but let's stop sharing that and see where these things are in terms of the periodic table, okay? I don't know if you can see the mouse on my screen in here. Can you guys see it or not? Can you see them? Okay, no. Okay. So let me go back into the screen in here with my handy. So we have carbon in here. Bromine is actually here. That's what I was warning earlier. For me, you have to find it on the periodic table, okay? So sometimes you might be confused with another B, so you have to really find where the element is. So the furthest to the left is carbon. Then after that comes bromine, which is in here, okay? And again, how many do you have in this case? You have only one carbon, so we can just say carbon. We don't have to say monocarbon in this case. And then we're going to add an IDE to bromine, so it becomes bromide. But how many do we have? We don't have mono, we don't have di, we don't have tri, we have tetra, actually, we have 4 of them. So it's going to be carbon tetra bromide, okay? So that's the naming that we're going to go with it for this case in this. And that's choice D in this case, okay? Carbon tetra bromide, and we added the IDE to the last one in there, okay? So this chapter is kind of light. The biggest thing in terms of this chapter for you guys is the assignment at the end of this chapter, which is the homework, which I'm hoping that you guys will take your time on it. So please do not start it unless you really have ample time. So that's the second assignment that you guys need to comment on in today's discussion, that we're not going to start on the homework unless we really have at least an hour or more to spare. So we have 2 tasks today. The biggest one actually is to go through that link I provided you and determine the physical properties of sodium and also the chemical properties, especially in terms of its reactions with oxygen and also with water. And the second one is do not start the homework unless you have spare amount of time to spare, at least for an hour or more. We're good? So this chapter is light. Does everybody understand what we have to do today? We have 2 tasks in the discussion afterwards.
Yes, sir.
Mm-hmm.
Okay. So I'll see you guys on Tuesday next week, where we cover at least, I think the next chapter is going to be a little bit heavier than this. So we probably, I'm glad the chapter 14 came immediately after the exam, otherwise we will have heavy tasks to do too. And chapter 15 is going to be a little bit of work next week, and 16 after that.
Okay.
Okay, guys. So I'm going to stop the recording now.